Hello guys, my name is EJ. I'm a tutor. So I'll be taking you guys PHS today, PHS 101/105. The topic we'll be looking at today is motion. So now we look at the definition. Start from definition of motion. What is motion? Motion is the change in position of a body with time, not just the change in position of body. Note that motion is the change in position of a body with time. Now, the next one is kinematics. What is kinematics? I'm sure we are all familiar with like the word kinematics. Maybe you have seen it maybe in your WAEC or like when you were in secondary school and all that. But what really is kinematics? Kinematics is just the study of motion of a body without involving the forces which cause the motion. Now, moving on to dynamics. Dynamics. What is dynamics? Dynamics is the study of forces and how they affect the motion of a body. So when we study different forces and how they affect the motion of a particular body, we call that dynamics. Now, moving on, we have a scalar quantity. Now, what is a scalar quantity? I'm sure we are all familiar with scalar and vector quantities, but what truly is a scalar quantity? A scalar quantity is a quantity which has magnitude but no direction. Now, an example of a scalar quantity will be speed. You calculate for the speed now, that's the distance over time. It does not involve direction, it's just the magnitude. You get your answer, the magnitude only. And then also energy is also an example, temperature, they are all scalar quantities. Now, what is a vector quantity? A vector quantity is one which has both the magnitude and the direction. An example is displacement, which is the total distance traveled. Total distance traveled with a particular direction, in a given direction. So now, another example is the acceleration, which is the change in velocity with respect to time. So to calculate your acceleration, you must also always include your direction. So that's the basic difference. We want to talk about the differences between a scalar quantity and a vector quantity. A vector quantity usually has a particular specified direction. Direction can be either positive or negative. Now, moving on to the types of motion. We have 4 types of motion. We have translational motion, we have rotational motion, we have oscillatory motion, and we have random motion. What is translational motion? Translational motion is the motion of a body from a point to a particular point without that body rotating or changing its trajectory. So an example would be maybe like you drive a car from maybe a location to another location, maybe like a street, maybe like you have a junction now, you drive a car from here to here, you walk from here to here. Your motion from walking from a particular point to the next point without you rotating, that is the translation. A transitional motion has occurred in that. Or maybe you just drove your car straight down the street. A transitional motion has occurred. So, what about rotational motion now? Rotational motion is a motion in which, permit me to use the word rotation because I would like us to all understand what we are saying here. So, an example is like the wheel of a car, that is rotational motion. The blades of a fan, rotational motion. Just to give you an idea, basic idea of rotational motion. The next one is oscillatory or periodic motion. What is oscillatory or periodic motion? It is a to and fro motion. So an example of an oscillatory or periodic motion is the swinging of a pendulum bob, a mass. If you attach a mass to a spring, the motion which occurs up, down, that's also an example of the oscillatory or periodic motion. So now, what is random motion? Random motion is a zigzag type of motion. It's a motion that it moves when an object or a body moves in an unspecified direction. It just randomly changes its direction. We call that a random motion. An example is the Brownian motion, suspended gas particles. All of that are random motion. So now we'll move on to the parameters used in motion. We have different parameters used in motion. The first one we're looking at is the v, which is usually used to denote final velocity of an object. Its unit is meter per second. Then the next one is the distance covered. What is distance covered? Distance covered basically is when you move from a particular point to another point without considering the direction. So when you move, let's say for example now, you are traveling. So you start your journey from a particular location, you cover maybe like let's just say, okay, from one point to another point, maybe let's say a point A to a point B, 100 meters. You move from that point B to a point C, another 100 meters. From point C to point D, 50 meters. So that's 100, 100, 50. Now, the total distance traveled from the start of your journey to the final position of your journey basically will just be 100, 100 plus 100 plus 100 plus 50. that would be 250 meters covered. That's the distance covered. So to give you an idea of distance covered, it is the unit is in meters. The time taken now. Time taken usually measured in seconds. Like how long did it take you to cover a particular journey to perform maybe like let's say for example now you are moving at a certain speed. You have you have covered a particular distance. So what's now the time taken? How long did it take you to really like to cover that whole journey, like the period of time that it's taken? That's basically what the time taken is for. Then the initial velocity. Initial velocity, you can just use it as, let's just say like the start of velocity. Sometimes it is 0 and sometimes it is not. So U is used to denote initial velocity in meter per second. Then we have acceleration. Acceleration is time rate of change of displacement. So it is measured in meter per second square. And then we now have the height now, the displacement. Let's say for example you drop an object or you throw an object vertically upwards in the air. So the height or the displacement, h, its unit is meters. Then we also have the g, which is acceleration due to gravity. As a physicist, you should know. Okay, I'm a physicist. So as a physicist, acceleration due to gravity. There's a force that acts on every object in the Earth. So it acts towards the Earth, like it's acting downward. As we are standing here on Earth, the force is acting downward. So now every object in the Earth now is under the influence of gravity, whether we like it or not, whether I want it or not, is under the influence of gravity. So it is very crucial in the study of motion to know about this G, which is the acceleration due to gravity, which affects all objects on Earth. The unit is meter per second squared. So we'll drop more videos. I'll be taking you guys in depth about motion. We'll do calculations. I would solve and prove the 4 equations, the first 4 equations of motion. We'll take questions. We'll take simple questions. We'll take complex questions. So you guys should look out for the next video.
Yeah, enlightened.